Okay, so first thing I want to say is if you hear any scratching, if I write, I apologize. I don't have my headset on, so the microphone on the computer picks up the scratching. Um, so all you see here, all this stuff is just me verifying that what you did is correct. And I got the same thing you did. I got the same equations. I got the same coordinates that you got. So then what I did is went over here and graphed them. So you can see I called equation A equation B. So the black equation is equation A. The red equation is equation B. And because they're both greater than or equal to, that's the one thing I did notice about yours. You just put equals, but I was wondering if that was just because you were typing it. But they should be greater than or equal to, because our baby wants at least 140 calories and at least 32 grams. So therefore, those should take care of that. So the greater than. So then I went to shade. So I did my test points. Test point is 0, 0. So when I substituted 0, 0 into my A equation, 0 plus 0 is greater than or equal to 140. So again, 0 plus 0 is greater than or equal to 140. That is false. So I do not shade towards 0, 0. Do not shade towards the test point. I'm going to shade away from it. So the black line, that's why the A shaded up. Same thing for the red, same test point, same results, comes up to be false. So therefore that one's shading up. So therefore my shaded region, you can kind of see is being implied here, it's everywhere up here. So now the question is, it's unbounded, so this graph is unbounded, so we don't necessarily have to have a solution. So now we look at the thing we're trying to min or max. The thing we're trying to min or max here is our costs. So in that case, if we want to minimize the cost, let's verify at least cost, there we go. And notice our cost values are all positive, so as my x's and y's get bigger, my costs go up. So therefore, this unbounded region is the scenario where I just keep buying more and more and more food and my costs keep going higher and higher and higher. So therefore, I do have a minimum though, and it will occur at one of my intercepts. So it's either going to be here at this point, it's going to be here where the two graphs intersect, or it's going to be here at this point. Now we know the B, we know this point here, we'll call it number 1, number 2, and number 3. We know 1 and 3 because those are our intercepts from over here. So the reason I wrote 1.5 for graphing, but I didn't lose sight of the fact that it's really 32 divided by 21. And then this one I wrote 2.9 for my graphing, but I didn't lose sight of the fact that it's actually 32 divided by 11. So this B over here is, this number 1 is the 2.9, but we're not going to use 2.9 unless it asks us to round to a certain decimal. We're going to remember that this is 32 elevenths, comma 0. Then number 3 up here, this point is coming from the first equation, and that's at 1.75. So that one's actually exact, so we don't have to worry about that one. So that's 0, 1.75. So then now we just need to find point 2. We find that using the intersection of lines. So I'm going to do that on the screen in the calculator so you can see it, just in case that's where you're struggling. So let me bring up my little graphing calculator and let me move it to the screen. Okay, so now, clear that out. So first thing I'm going to do is go into my matrix, edit my matrix, and I'm going to see this is 2 equations with 3 columns, so it's a 2 by 3, and I'm going to type in my values. I have to scoot it up just a tiny bit. I can't get to my 0 key. There we go. I hope that's still on the screen for you. So 60. My next one is 80. My last one is 140. Then my second equation is 11, 21, 32. I always recommend double check your numbers before you move out of here, because if you just have one little typo, it messes everything up. All right, so now I know that's back on the screen. So now what we're going to do, quit out, back to our blinky screen, make sure there's nothing in here. Then we're going to go back into the matrix. We're going to reduced row echelon form of matrix A. And now when I hit enter, it tells me my answer. So those 2 lines intersect at the point of x equaling 1, y equaling 1. So therefore, my point number 2 is 1, 1. And remember, we don't care that they were actually greater than or equal to, because when we're trying to find the intersection point, that's where it would be. That would be the equals to part. So the shading doesn't matter. We want to know where they both intersect. This is the whole concept from 3.1 and on. So now we have our three values. We substitute these into our min or max equation, which was I forgot. Let me grab. There we go. It was 0.32x plus 0.52y. So we sub each of these in, and so this one would give us a value of p equaling 0.52 times 1.75. I can ignore the 0 because 0 times, that's just going to be 0. So this is going to give me some value. This one would be 0.32 plus 0.52y, excuse me, 0.52, because when we substitute in 1 and 1, it just gives us those values. Then the third one is going to be 0.32 times 32/11. And again, because it's 0 y's, that's going to make those 0. So now I find out which one of these is the smallest value. And when you do that, you end up finding out the smallest value is this one right here at 84 cents. So the value that minimizes our cost would be when we buy one of each. I hope that helped with whatever your situation was.